Hello everyone, I am Deeptangshu Bane from ECA section and I am going to present a concept video of the subject engineering physics on the topic Einstein's photon theory and photoelectric equation. The contents of my concept video are Einstein's photon theory, Einstein's photoelectric equation, and my conclusions. First, let's discuss Einstein's photon theory. In March 1905, Einstein created the quantum theory of light, the idea that light exists as tiny packets or particles, which he called photons. Alongside Max Planck's work on quanta of heat, Einstein proposed one of the most shocking ideas in 20th century physics. We live in a quantum universe, one built out of tiny, discrete chunks of energy and matter. Next, in April and May, Einstein published two papers. In one, he invented a new method of counting and determining the size of the atoms or molecules in a given space, and in the other, he explains the phenomenon of Brownian motion. The net result was a proof that atoms actually exist, still an issue at the time, and the end to a millennia old debate on the fundamental nature of the chemical elements. And then, in June, Einstein completed special relativity, which added a twist to the story. Einstein's March paper treated light as particles, but special relativity sees light as a continuous field of waves. Such a condition took a supremely confident mind to propose. Einstein, at age 26, saw light as wave and particle, picking the attribute he needed to confront each problem in turn. Einstein wasn't finished yet. Later in 1905 came an extension of special relativity in which Einstein proposed that energy and matter are linked in the most famous relationship in physics, E is equal to mc square. The energy content of a body is equal to the mass of the body times the speed of light squared. This equation predicted an evolution of energy roughly a million times more efficient than that obtained by ordinary physiochemical means. At first, even Einstein did not grasp the full implications of his formula. But even then, he suggested that the heat produced by radium could mark the conversion of tiny amounts of the mass of the radium salts into energy. Now, let's discuss Einstein's photoelectric equation. In 1905, Einstein expanded Planck's notion by deriving his own equation that correctly described the features of the photoelectric effect. He presupposed two things. Radiation with frequency nu consists of a stream of discrete quanta or photons with energy h nu, where h is Planck's constant. Photons travel at the speed of light through space. When photons and electrons in the emitter's atoms collide, when radiation of frequency nu is incident on a photosensitive surface. During such a collision, the photon's whole energy is transmitted to the electron with no time lag. A photon is not a material particle but quanta of energy. The incident photons absorbed energy h nu by an electron is utilized in two ways. The electron uses some of its energy to break free from the atom. The minimum energy required to free electron from a given surface is called photoelectric work function psi 0 of the material of the surface. The residual energy h nu minus psi 0 emerges as electron kinetic energy. If the electron does not lose any of its energy in impact with the surface and exits with the greatest possible kinetic energy, therefore 1 by 2 mv square max is equal to h nu minus psi 0. This will be our equation 1, where m is equal to mass of the electron, nu max is v max is equal to maximum velocity of electron. All the photoelectrons emitted from the metal surface do not have the same energy. The photoelectric current becomes zero when the stopping potential is sufficient to repel even the most energetic photoelectrons with the maximum kinetic energy, so that the stopping potential in volts is numerically equal to the maximum kinetic energy of photoelectron in electron volts. Now, half mv square max is equal to E nu 0. This is the second equation where E is equal to magnitude of the charge of an electron. From 2, we have half mv square max is equal to h nu minus psi 0, or E in nu 0 is equal to h nu minus psi 0. This equation in Einstein's this equation is Einstein's photoelectric equation. With the aid of Einstein's photoelectric equation, we can now describe all of the features of the photoelectric effect. If the frequency of incident radiation is decreased, the kinetic energy of photoelectrons also decreases. And finally, it becomes zero for a particular frequency, say nu. Nu is called the threshold frequency. Thus, nu is equal to nu 0, then maximum kinetic energy is equal to half mv square max is equal to 0. Therefore, from equation 1, we get h into nu 0 minus psi 0 is equal to 0, or h into nu 0 is equal to psi 0. Therefore, Einstein's equation can be written as half mv square max is equal to h into nu minus nu 0. From the above equation, we can say 3 points. When nu is greater than nu 0, the photoelectrons are emitted with some velocity. When nu is less than nu 0, no photoelectrons are emitted. And when nu is equal to nu 0, photoelectrons are just emitted but with zero kinetic energy. A more intense beam, according to quantum theory, includes higher number of photons. As a result, the number of photon-electron collisions increases and more photoelectrons are released. This explains why the photoelectric current increases with incoming photon intensity, because the photoelectric work function psi 0 is constant for every given emitter. Equation 3 demonstrates that the kinetic energy max of photoelectrons grows with the frequency of incoming radiation but does not rely on intensity. Now, coming to my conclusion. Einstein, in his quantum theory of light, stated that light is a wave that interacts with matter as a packet of energy, also known as a quantum of energy. He later proved it in his theory of photoelectric effect and also established the photoelectric equation. Albert Einstein went on to win the Nobel Prize in Physics in the year 1921. In today's world, photoelectric effect and photoelectric equation have become vital for the creation of many devices such as solar cells, photodiodes, etc. Thank you.